Hello Stackers! Welcome to Introduction lecture of OpenStack Installation and Deployment course. In this lecture I will introduce myself and give you an overview of the course goals. Then you will learn what is in the course, what subjects you will get covered here. We will talk about course requirements, what you should know to get most out of this course, and what kind of hardware and software is useful to practice presented material. In the end, I will give you some best practice hints related to this course. OpenStack Installation and Deployment course is designed to help you achieve following goals. Understand what it means to install and deploy OpenStack, what it takes to have a working OpenStack deployment. I want you to understand various deployment methods, like installing OpenStack services as systemd units or deploy as containers running in Docker container runtime environment. After you complete this course, you will understand what installation infrastructure you need to successfully deploy OpenStack with required availability, security, or quality of service. I want you to be able to perform manual installation of OpenStack, at least the core services, enough to run basic user workloads. You will get knowledge and tools to deploy OpenStack in automated way using official OpenStack deployment projects, both simple ones like DevStack, suitable for demo all-in-one installation, as well as more advanced like Kolla-Ansible, good for production-grade multi-node deployments. We start the course by doing a quick overview of OpenStack architecture, focusing on services it is composed of. I will give you enough overview to understand what is necessary to install and deploy this cloud operating system. Further down the line, you will get good understanding of both all-in-one and multi-node installation. The former is when we install all OpenStack components and services onto one host, like a laptop you carry around. The latter is when you segregate and split components and services to install them on many hosts. You may want to do this in order to achieve scalability, but maybe also high availability of OpenStack services. We will experiment with various deployment architectures, installing OpenStack with different storage backends, for example. To make things easier and quicker, I will show you some deployment examples by installing OpenStack in virtual machines. This installation environment is particularly useful for experiments, or we should rather say development work. Once we get through manual installation, we will focus our attention on automating this daunting task. When you have to do some 500 installation steps, mistakes and errors are inevitable. This is why OpenStack community developed automated deployment tools like OpenStack Ansible or Kolla. For all-in-one deployments, we will take a closer look at Backstack, the open source project supported by Red Hat community, as well as DevStack, the OpenStack community project, particularly popular among OpenStack contributors and developers. There is a lecture in the course on how to deploy DevStack-based OpenStack installation in Google Cloud Platform Virtual Machine. So, if you don't have a suitable PC or laptop, but still want to experiment with some non-core OpenStack services, you can take advantage of the course scripts to quickly fire up OpenStack in public cloud. On the other hand, once we do multi-node bare metal server deployment with Kolla-Ansible, we implement a slightly more complex example workload with a database virtual machine, some web server virtual machines, and a virtual load balancer. We take the opportunity to implement Cloud Init startup scripts and marry all this with GitHub version control system. What else you find in this course? Well, there is controller high availability. We practice failure and recovery of controller node. We do most exercises using Ubuntu Linux, some on CentOS. For VM-based scenarios, we use QEMU hypervisor emulator, but for bare metal deployments, KVM is used as hypervisor. For storage deployments, you see LVM, but also Ceph in multi-node scenarios. For network agents, we use Linux bridges in simple configurations, but all production-grade scenarios are based on OpenVirtualSwitch. You will see a number of other non-OpenStack technologies throughout this course, like VirtualBox and Vagrant to automate virtual machines provisioning. There is Ansible and Docker used in automated deployments. We use GitHub to host some of the scripts and configuration files, so clone and branch and fork anytime you find it useful. I try to automate many of the repeatable tasks related to OpenStack installation and deployment, so you get scripts, and more scripts in this course. You are free to copy and modify them any way you want. I hope you find them useful in your OpenStack deployments. To take full advantage of this course, you should have some sysadmin knowledge and skills, like reasonably good experience with Linux. OpenStack runs on Linux, so you need to understand Linux and its administration. OpenStack combines orchestration of compute, network, and storage resources, so you should have good level of network knowledge and skills. Next one is storage, but also virtualization. Getting OpenStack to work on bare metal servers, including compute nodes with KVM, is child simple. But when things go off-road, you need to understand it in order to troubleshoot issues. I hope you have some experience with cloud technologies like Amazon Web Services or other public cloud platforms. You need this to be able to use OpenStack you will install. Best is, of course, if you are already familiar with OpenStack itself. If you would like to repeat some of the installation and deployment scenarios presented in this course, you need access to some good hardware. A PC or laptop with 8 GB of RAM and CPU capable of virtualization is the absolute minimum. However, you will be able to repeat only the simplest examples from the course. With 16 GB of RAM and 4-core CPU, you can do most of the VM scenarios, maybe except of the ones with 3 controller nodes or Ceph. With 32 GB of RAM, you will repeat all VM-based scenarios. As for the bare metal deployments, I use 4 hosts in the examples. One has 4-core CPU, 24 GB of RAM, and 256 GB SSD. Second has also 4-core CPU, 32 GB of RAM, and 512 GB SSD, while third has 8-core CPU, 32 GB of RAM, and half a terabyte of NVMe disk. Each one has 1 gigabit Ethernet card. I use managed switch, very simple one with 8 ports. I configure 3-4 VLANs in it suitable for all presented scenarios. I also use a MacBook to run a VM used to host deployment tasks and to record screen capture video for the course. If you have any questions or issues related to this course, send me a message or post it in the course Q&A. I do my best to answer quickly. Many lectures have additional resources like installation instructions, checklists, scripts, which you will see in lecture videos. Check it out and download if you would like to repeat exercise. In lecture resources, you can also find links to download software or links to GitHub repositories where I keep the scripts and configuration files. Clone or fork them. Last but not least, the course is linear. I have designed it to be enjoyed in progress, starting from lecture 1 through 3, 4, 5, and so on. If you prefer to cherry pick the content, you may consider checking some of the preceding lectures for resources I'm just mentioning. Have a great course, and let's move on to real stuff.